The dock of the CSSN, the Navy Support and Naval Experimentation Center of La Spezia. 4 autonomous vehicles, 3 underwater and 1 surface-going, are lowered into the sea to test a new system that allows the robots to work together to achieve the objectives of a mission. The technologies behind this test are the result of 3 years of intense work by researchers involved in WiMUST, a project funded by the European Commission under Horizon 2020. The goal of WiMUST was to develop a system for the execution of underwater geotechnical surveys by a swarm of small autonomous vehicles without using the large and expensive support vessels needed to date. The idea was to use hydrophones towed by autonomous underwater vehicles as a huge antenna able to collect the echoes from the sea bottom of the waves produced by acoustic generators on the surface, the sparkers. In order to geo-reference the seismic data acquired, and also to control the underwater vehicles, it is necessary to know their position with great precision, an extremely complex problem since GPS cannot be used underwater. To solve it, the WiMUST researchers developed an innovative solution, integrating atomic clocks into the acoustic modems on board each vehicle. In this way, several vehicles on the surface take turns transmitting their position through the acoustic modem. The underwater vehicles receive the position and, thanks to the atomic clock, they can immediately calculate the distance from the vehicle on the surface and localize with techniques similar to those used in GPS receivers. One of the advantages of this technology is that it also works with a very high number of submerged vehicles, as long as each of them is reached by the signal sent from the surface. In the demonstration at the CSSN of La Spezia, the technologies developed in WiMUST were tested in an operational context closer to the needs of the Navy. The goal was to navigate surface vehicles and those immersed in a completely autonomous formation. The body of water where the test took place was something of a homecoming for the researchers because it is precisely at the SeaLab, hosted by the CSSN, that most of the activities of fine-tuning the vehicles and the algorithms of navigation, guidance, control, and communication of the WiMUST project occurred. The demonstration used the Ulisse autonomous catamaran made by ISME and 3 Folaga, autonomous underwater vehicles made by Graltech. 2 of these were configured to navigate on the surface in order to provide the necessary support to the location of the 3rd Folaga, which navigated underwater instead. After a ride on the surface to stabilize the swarm of vehicles, the Folaga that had been prepared for submarine navigation received the dive command sent from the console. Once underwater, the vehicle was able to continue the navigation in formation, thanks to the data received acoustically by the 2 Folagas on the surface. The same control software package was used both on the catamaran and on the Folaga, demonstrating its interoperability. After several laps, the control console sent a stop command to the submerged vehicle. The signal was received via radio from the Folaga on the surface, which retransmitted it to the underwater one through the acoustic modem. And thus the mission came to an end, a complete success.